Everyone, so today we will be solving another interesting problem, number 50, POW of x comma n. This is a very good problem to understand recursion. So the problem says implement p of w x of n, which calculates x raised to the power n, that is x to the power n. Okay, so one thing we need to understand here, x is our base and n is our exponent. Okay, and we are given three example test cases, and so we'll use the property of x raised to n to model our function, this my power, my POW. So we'll name as that f of x of n. So whatever properties we observe for x of n, we'll model this to the function x comma n which we need to design. So this is how we start. So the first property that we see is that n is even. Okay, and so 2 raised to 10 is, we can write it like this, 2 raised to 5 square. So this basically boils down to x raised to n is equals to x of n by 2 whole raised to the power of 2. So this basically is, so if I model this, so it becomes, so what we are doing is we are dividing our power by 2 and raising it to the power 2, so which basically becomes multiplied times f of x comma n by 2. Okay, so now the second is when our n is odd. So in that case what we need to do is we'll observe another property of linear algebra of exponents. So if 2 raised to 3, we can write it like this, 2 into 2 raised to 3 minus 1. So this basically x raised to n is equals to x into x raised to n minus 1 when n is odd. This was, so we'll model this property. So this is how we can model this. So basically we have f of x comma n, which becomes x into f of x comma n minus 1, right? And this is what we need for modeling our properties. Right, and so the third and the last case that we need to understand is when n is negative. Okay, so when n is negative, then basically this is x raised to n, where n is negative, so we can write it like this, 1 divided by x raised to minus of n. So basically 2 raised to minus 2, we can write it like 1 upon 2 square, and we can calculate 2 square, so which is 4, so that can be computed. So if we model this back, we can model it like this. So basically f of x comma n is modeled upon 1 of x comma, we are just passing minus n to the function that we are going to design. So we need this for our function. So this is when n is negative, and so these were the cases when n is positive. This is when n is even. This is for n is odd, and this is for n is negative. Okay, and so don't need this, and we need to write out 2 more base cases, like when we want to stop our recursion. So we can observe that if x is 0 then x raised to n is nothing but 0 raised to n, which becomes 0, and when n is 0 then x raised to n is equals to x raised to 0, which is 1. So these will be our function return values. So like we discussed, if our n is negative, then we want to return the function call and the negative exponent, and if n is odd, then we will return into the function and n minus 1, and if n is basically even, so which is the last case that in which we want to return. So we can write it in else, or we can just write it separately. We can do self dot my pow x and n by 2, and we need to do it this twice. So let me store it in one variable, and we'll return the square of that. So y into y, and our base cases that if n is 0, then we'll return 1, because x raised to 0 is 1 when x can be positive or negative. And the another base case was x is equals to 0, then we need to return 0, because 0 raised to any power of n will always return 0. So this is our negative exponent case when n is negative. This is for when n is odd, and this is for when n is even. Okay, so let's run our example test cases and see how our code performs. Oh, this is self dot my pov, because we are calling the function again. So it has been accepted. Let's run our code and submit. Okay, so it's faster and better. So that's how you solve this problem, and the time complexity for this problem is O of log of n, because we are dividing the function in 2 over here and we are shortening the function one by one as we go down the recursion, and the space complexity is O of 1 because we are not using any memory to store the functions call. So yeah, that's how you solve this problem. Thank you.